Hello, everyone. This is a video doing some examples, as I did the previous one, going quickly show how you can go over the textbook to see the layout. So let's do the conversions for an example. So let's say you have, let me call it find the set of conversions. Of course, if it does, or let's say this series here. All right, so if you watched the previous video, you know that we're going to do the test, the ratio test, okay? So n is that first part, which is 23 over n squared plus 10n. That makes a sub n plus 1 to be 23 over n plus 1 squared plus 10 times n plus 1. So we can do the limit for the ratio as n tends to infinity. And this is not too much to do because you're going to do the first fraction, you're going to do reciprocal for the second one. So you're going to end up with being, with having this here and the other one here. And I think you can try it, but when you open up all this and similar to what I did in the other video and what you did, of course, in calc, you'll find that the limit is 1. And that tells us since x naught here is this. So the upper bound is 10 plus 1, which means 11. And the lower bound is 10 minus 1, which is 9. So we want to find out what happens here on there. So for x equal 9, you're going to try it in this summation. And you get this. And that, so you substitute x equal 9 in it, and you get that. So as you see, this is an alternating series, which means it converges. So alternating converges, and the limit would be 0 when you look it up. So let's check the upper bound there. I wrote this below here. And if you remember from calc, this is the P series. But you can test the limit and it does converge. And that P is 2. And and from let's say A, B, and C, we get that the set of conversions is 9, the closed interval 9 to 11. Okay. Other things we can do in here is, let's say you need to find the expansion or the power expansion. For, let's say, for the power expansion, of course, from this, for the sum of two functions given f of x is this summation, and g of x is this summation. As you see, we have here different, they are not compatible for addition. So we need to make them compatible and then be able to do that. So the easy way is to introduce new variable as k equal n minus 2, and that makes n equal k plus 2. So this will be, so n equal 2. So now if n is 2 here, then k is 0. Then n is k minus 2, so negative n will be negative k minus 2. Alright, so negative n minus 2. And this n minus 2 is k. All right. One thing that's interesting with this, so let's bring down this one. All right, so someone you say, well, you can do it now because you have n and k, but we can because look, it doesn't matter what the variable is. I can rewrite this now as n. So let's say I pretend now this is what I have, right? So the question, can I add these two? So yeah, I mean, if you say now this is I, it could be, I can rewrite even all of them as I, right? But the question, I think, in the software wants n. So since it wants n, we can do it. But just show you, I can introduce I here and instead k, and introduce I here instead n, and be the same. Or I can just rewrite it this way, so not to make it too confusing. And this just comes. All right, so now you see that if you need to combine, you have xn, right? What do you have as a, it's a common factor. When you factor it out for these two sum, then you will have 1 over n plus 2 and plus e to a negative n minus 2. And the summation is going to be this, and that's the sum. All right, so let's do another one. I think if you're asked for to find for a derivative or something, you can do that. But another question, when you're given the expansion, yeah, let's do it. Let's do one more, because that goes kind of just like what you know already with the derivative. Find the power series expansion for f prime of x given f of x to be this series here, n plus 5 is 7 times x. That's right. Let's fix this. All right, so you know how to do this. You're just gonna be this summation, but it's gonna start from 2, and n plus 5 is already there. Then this becomes from like just like the power rule. All right, and this will become n minus 1 minus 1, so n minus 2. So it's not bad. Another one with the same thing. But let's do, if you just want practice how to rewrite. So let's say express this given series because sometimes the textbook shows you that you need to expand and see the pattern, but I showed you in form of xn or xk. All right. So yeah, so I'll focus on this. I'll say k equal n plus 8. That means n equal k minus 8. Right, so now, so if you see n is 8, that means 8 plus 8, that means 16. Um, so let's just put it as k here. So that's 16. Then n is k minus 8, k minus 8 minus 3, k minus 11, k minus 8. Then this is okay. Thank you.